today we're going to be looking at using formulas. The subject of a formula is a pronumeral that usually sits on its own on the left-hand side. So for example, if we have y equals mx, we've made y the subject. It's on the left by itself. A pronumeral in a formula can be evaluated by substituting numbers for all other pronumerals. So as long as there is only one pronumeral that you don't know the amount for, you can solve it. So for the equation up above, y equals mx, if m equals 2 and x equals 4, we can work out the value of y by substituting m equals 2 and x equals 4 in. So I have y equals 2 times 4, so y equals 8. A formula can be transposed, rearranged to make another pronumeral the subject. So using y equals mx, as we've used up the top, we can make x the subject by dividing by m on both sides. Now that's the same as what we've done when we've been solving equations. If I want to get x by itself, it's m times x. The opposite of timesing is dividing, so if we divide both sides by m, we end up with x equals y over m. So now I've made x the subject. Okay, example 1. Substitute the given values into the formula to evaluate the subject. So we have e equals 1/2 mv squared, when m equals 4 and v equals 5. So first off, you're working out, you should have the equation. That stops us making any mistakes when we're moving our eyes backwards and forwards. So we know that m equals 4 and v equals 5, so we're going to substitute those in for the pronumerals. So I have e equals 1/2 times m is 4, so substitute 4 in, times v is 5 times 5 squared. Then we just evaluate that, so e equals 50. I'd like you to pause the slide there and write that example down, please. When you're ready, press play. Okay, example 2. The area of a trapezium is given by a equals h on 2 outside of a plus b. Given a equals 12, capital A equals 12, little a equals 4, and little h equals 6. Find b. Now, write your formula down first. So we have h over 2 outside of a plus b. So for anyone who doesn't know the formula for an area of a trapezium, the small a and b are just the side lengths of the parallel sides. The h is a perpendicular height, and the capital A is just the area. So my formula reads, the area equals the perpendicular height divided by 2 times the sum of the two parallel sides. Okay, so we want to find b for now. So we know a equals 12, small a equals 3, and h equals 6. So the area is 12, one of the parallel sides equals 3, and a perpendicular height equals 6. We want the other perpendicular side. So if I'm substituting everything we know into the equation, we have 12 equals height over 2, so 6 over 2, and in brackets we have 3 plus b. So we need to simplify that, so 12 equals 3 outside of 3 plus b. So with this one, what we're going to do, rather than expand it out, we're going to divide by 3 on both sides. Now the reason I'm doing that is because when I do 12 divided by 3, it equals 4. If it wasn't a whole number, then it might be easier just to expand it out. But it doesn't really matter which way you do it. So I end up with 4 equals 3 plus b. So solving this one, we're going to subtract b3 from both sides, and we end up with b equals 1. So turning that around, we end up with b equals 1. So the two lengths of the parallel sides are 1 and 3, but we've found b there. Okay, I'd like you to pause the video there, get that down for me, and then press play when you're ready. Okay, example 3. Make b the subject. we have, and this is b, so we have c equals the square root of a squared plus b squared. Now, again, as per the last example, the b is not out by itself, so we can't get rid of it straight away. We have a square root sign here, so that's similar to brackets, and we need to get rid of those first. So, the opposite of square rooting something is squaring something. Okay, so if we want to get rid of the square root sign, we'll square both sides. So we end up with c squared equals the square root of a squared plus b squared, and we square all that. That will cancel those out, and we'll end up with c squared equals a squared plus b squared. Okay, so we want to get rid of that a squared because we want b by itself. So let's subtract a squared from both sides, because remember it is just plus a squared. Don't worry about the square root or anything because it's just plus a squared. So we end up with c squared minus a squared equals b squared. You might remember this from when we did Pythagoras' theorem in year 8, changing the formula to find the shorter side of a right angle triangle. Okay, we have b squared. We need to get rid of that squared, so the opposite of squaring something is taking the square root. So if I take the square root of both sides, I have the square root of c squared minus a squared equals the square root of b squared. Now on the right hand side, the square root and the squared is wiped out, or they cancel each other out, but we can't do it on this side, okay, because there's more than one term there. So our answer ends up being b equals the square root of c squared minus a squared. Turning that round to change the formula, we end up with b equals the square root of c squared minus a squared. I'd like you to stop the video there, write all that down in your book. Any problems, make sure you ask in class. Thank you.